The date is July 4th, 2012, and something incredible was happening in Geneva, Switzerland. Researchers at CERN's Large Hadron Collider were announcing a groundbreaking discovery. Almost 50 years after Peter Higgs proposed the theory of the Higgs field, evidence of the Higgs boson was finally found. In order to find the Higgs boson, researchers at CERN used the Large Hadron Collider, or the LHC, which is the most powerful accelerator in the world. The LHC is a giant machine that makes high-energy particles collide at almost the speed of light. Before we can get into what the Higgs boson is, we need to discuss a bit of quantum field theory. The theory says that all fundamental particles are just excitations, or vibrations, in different fields, and that these fields fill the universe. For example, an electron is just an excitation in the electron field. Every single elementary particle has its own field, and these fields coexist. There is, however, a flaw with this theory. If we go back to our electron example, we see that the theory assumes electrons are massless. After all, if they're just vibrations, what could give them mass? However, we know that electrons do have mass. But why? Well, that's where the Higgs field comes in. The Higgs field, like any other quantum field, is everywhere in the universe, and the Higgs boson is just the excitation of the Higgs field. Particles can go through the field, and as some do, they bump into Higgs bosons and get slowed down. Every particle has the potential, and ideally wants, to travel at the speed of light. However, it is their interaction with the Higgs field that prevents many particles from achieving this. When the electron travels through the Higgs field, it is constantly greeted by particles from all directions. While this process continues, energy is transferred from the Higgs particles to the electron, then back and forth again as they continue to bump into each other. The electron, in a way, is trapped in between the chaos. Energy is thus confined in this state, and this is how the electron gains mass. So why do particles like photons exist without mass? Photons are massless, and they can travel at the speed of light because they do not interact with the Higgs field, and therefore don't get slowed down and don't have mass. This can be a bit confusing, so it helps to use a metaphor. Physicist David Miller came up with the example of a cocktail party full of political party workers. They are all distributed around the room, talking to their nearest peers. If an ordinary person comes into the room, everyone would continue to chat amongst themselves. The person can walk through the room without causing any uprisings. But, if a famous politician enters the room, everyone would then start to hover around the politician, forming a cluster around her. As the politician moves across the room, she attracts the workers around her, and thus is always surrounded by a cluster of people, allowing her to acquire a greater mass. In this case, the photon is like the ordinary person moving freely, and the electron is like the famous person, constantly being trapped by other particles in the field. Hopefully, the Higgs field makes more sense now. The Higgs boson, however, is incredibly unstable, meaning that studying it will be very difficult. Scientists are beginning to learn more about both the boson and the field, and think that the Higgs field may be able to explain things, like dark energy and cosmic inflation. Some even think that the Higgs boson confirms of an unstable universe inching towards doom. While we don't yet know where the discovery will lead, we do now know why everything in the universe isn't zipping around the speed of light, meaning we know why things have mass. And that's pretty cool.